Hello all, welcome to session 3. In the previous two sessions, we discussed in details about what is a platform event, what is an event-driven software architecture, how does Salesforce provide us the flexibility of using an event-driven software architecture in Salesforce using platform events. How do you define a platform event definition? How do you create a platform event using the two methods, which is either a new operator or using the sObject type.new sObject. This is from the Apex perspective. Post that, we also validated on how could you publish a platform event and the result which you receive or the response which you receive on EventBus.Publish, what kind of response is it? Is it synchronous or is it asynchronous result, right? So we'll be continuing from this point, and just a quick recap to understand that the EventBus.Publish, whenever we use the EventBus.Publish to publish a platform event, it actually shows you the results of a synchronous publishing, which means that it's not actually published to the event bus so that it could be consumed by the subscriber. It's just published to the Salesforce queue and consequently will be published to the event bus. So it's a two-step process. So first it will be published to the queue, and from the queue it will be published to the event bus. From there on, it can be eventually consumed by the subscriber. Now, the most important question that comes into everybody's mind is what happens in case if there is a failure? What happens if my message is not published onto the event bus? If it doesn't persist in the event bus, how would I be notified? And what could be the remedial measures that I could take? For example, could I create a task? Could I create some subsequent steps like creating a task? Could I republish those events? So as per Summer 23 API version 58, the Salesforce has introduced two new interfaces which could precisely help us with the scenario which we have discussed about. That is, in case if there is a publishing failure, we could implement a class that would implement these two interfaces, and depending upon what are we looking forward to. In case if you're looking forward to track all the events that have failed, we could implement the publish failure callback class. In case if we are looking to track what all events have succeeded, we could implement the event publish success callback class. So Salesforce provides us the provision of creating a class that implements these interfaces, and it will be providing us the information of the success or the failure responses. And we could take remedial measures, including the republishing of the platform events. Let's see that in action. Go to the developer console, and we'll be creating a new Apex class. We'll call it as insurance failure CB, which is for callback class. Insurance is already a platform event that we have created in the last few sessions. It has 5 custom fields along with the 4 standard fields in it. In case if you are not aware about the platform event insurance, I would request you to go through the last 2 sessions to make a good hold of this logic. So we'll move forward. As I said, we'll be implementing the EventBus.Event Publish Failure Callback. Right? Now, whenever you implement an interface, there would be a method that would be defined in an interface, which would be mandatory for you to be implemented in the class itself. Now, as you can see, once the compiler has understood that we are implementing EventBus.EventPublishCall failure callback, it has automatically shown us an error saying that, hey, you'll have to implement a method on it. And that method is called as onFailure, and it will be taking an argument, which is EventBus.FailurResult. So let's move forward and implement that. Public void, since it will have no return type, onFailure, and it will be EventBus.FailurResult. We'll store that in results, right? And here we'll be able to get, so it only has one single attribute, which is list of strings, list of failed event UUIDs. Let's say that, and you can get results.get event UUIDs, right? So as could be clearly seen, we have created a class which implements the EventBus.EventPublishFailureCallback interface. The interface requires us to implement a method which is onFailure. It has an argument results. The results, when we narrow down to the results, we could get all the event UUIDs of the event messages which have failed, right? The event UUID, as I explained in my previous sessions, is actually a universally unique identifier, and we would get the event UUIDs of all the messages that have failed. Now, based upon a common understanding, what we would do next is we would want to republish it, or we would want to create a task actually, right? So let's take an example of republishing these events. Now, a common understanding once we get a set of IDs is to actually query for those records, right? So inside this loop, let's say query for the platform events. So we'll store that in list of insurance underscore underscore E, list of insurance equal to, I'll just say select ID from insurance underscore underscore E, where event UUID in the variable, which is list of failed event UUIDs. Right? Let's save this and see what happens. As soon as you save this, you'll get an error message which states entity type insurance underscore underscore E does not support query. Now, if I jog your memory, when we were discussing the difference between a custom S object and a platform event, we clearly stated that although they may be similar in many aspects, but in terms of a platform event, you cannot edit or delete the messages of a platform event. You cannot expose them in UI. That is, you cannot have a layout for them. You cannot expose or create a list view for them. And the third and the most important one was that you cannot execute an SOSL or an SOQL on the event messages, right? So the ideology behind using the event UUIDs to query for the platform event and then try to republish is not valid, right? So I'll update this. Now, so at this point, we are kind of stuck. But if we think of it logically, then the only way to get out of this situation is to actually understand or see if there could be a relationship between the event message and the record from which the event message was generated, right? So if I go back to the example of the account record, which was acting as a customer for us, and we were requesting the account, which is actually a client or a customer, that if they need travel insurance. If they say yes, we would publish a platform event message based upon the details of the account and send that across to the external system through the publish feature. The external system would consume that platform event message and send out the relevant documents required to the customer. This was the entire use case, right? So here, as you could observe, the major players are the account record and the information of the account record, which is used to publish the platform event message. So the two entities that should be related to one another is the account and the event message, right? Now, the next step which we'll have to take is we'll have to see that how could we establish that relationship first thing while we are trying to publish it, and how could we send that information on to the failure callback class, right? So these are the two things which we'll be taking into account. In order to do that, I've created a small minor UI, right? So let's go here. We're going to the account record. Excel Corporation, details. And if you could see here, we have created a small section here called as travel information. Travel information consists of the fields which we spoke about. Required travel insurance, this would be the checkbox. So as soon as this checkbox is checked, the from destination to destination number of bags, these are the three fields which would be populated on the platform event message, and consequently the platform event message would be published. Now, in order to do so, we'll be using the apex trigger. Just to put a disclaimer forward, the effort of this particular session is to make you understand the relevance of platform event and not about the best case or the best practices around the apex triggers. So we'll be using a very a minimal example wherein we are not following any concepts of trigger handler classes or the trigger framework in itself, because the entire idea of the session is to explain you about the platform events or the publishing of the platform events. So going back to our class, we'll just create another new Apex class. Create Apex trigger, and we'll name it as travel insure update trigger, right? We'll keep it simple. Let us create. We'll add another method here called as after update. Again, as a disclaimer, this is a demo session, hence it doesn't focus on best practices around trigger implementations like handler classes or frameworks, trigger frameworks, right? So let's see if the trigger is after and trigger is update, right? So what we'll do is we'll loop through the accounts, account ACC trigger dot new, and for each account we'll have to check if ACC dot travel insurance. I have to check the API name for the field. Second, we'll be checking the edit object, fields and relationships, required travel insurance. So we'll say dot required travel insurance is not equal to trigger dot old map dot get account dot ID dot require travel insurance. Okay. So we're trying to fetch the value, and we'll also ascertain if the value for required travel insurance has been checked as true, right? If this is the case, then what we'd be doing is we would be actually adding a platform event. So let's declare a platform event here, list of insurance underscore E, list of insurance. Be copying this part here. Let's save this, right? We'll instantiate a new here, insurance underscore E. Or rather than doing this, let us create a list of accounts actually. List of account equal to new list of account, right? And we'll add this to the list of account actually. List of account dot add ACC. Right, we have missed a semicolon here. It's both of these errors. Right, line number 12, we are missing a semicolon. Yes, we do. Okay, so this loop ends here, wherein it goes through each of the accounts that have come to the Apex trigger. If the required travel insurance has been checked as true, it will actually add it to a list variable, which we have named as list of account. Now let's move out and we'll say we'll check if the list of account is empty, right? And do this. Okay. Now what we need to do is we are actually looking forward to instantiate the object, right? So here what we'll do is we will navigate through account records, The specific reason we are doing it in this manner, we could have directly created the insurance platform event directly from the above logic, as I told you, but we'll be explaining on why we are looking forward for this particular approach. So here we'll instantiate in this insurance underscore E, insurance underscore E, INS dot, and then we'll be copy pasting some of the fields which we had used in some of our previous sessions, actually, just for the ease. So this one here, right? And instead of doing this, we'll name it as insurance. So this is the example which we took in our session 2, wherein we populated it in the Apex, the developer console directly, right? So here what we'll do is we will directly populate it from account variable, which is account.id, and then it will be the account.name, right? And it will be the account.acc dot the from destination. So we'll populate it with this, and then it will be acc.to destination, right? This is all we had. Now we also have the list of account IDs, right? So list of, not account IDs, list of the platform events actually. So we'll add this instance to that, and it will be insurance. Okay. Missed it here. Sounds good. Now, once we have the insurance ready, we again loop through it. And here is wherein we'll see the difference actually. So list of insurance dot is empty. Not. And we have the list of database dot save results, right? We'll be using as results for now. And EventBus.Publish. I want you to carefully see the EventBus.Publish parameters which are available in your screen, right? So what it shows is, if I try to get it a little more, it shows you 4 publish method over its method overloaded actually, right? And the arguments which have been provided to the publish method are different for each one of them. For instance, the first one, it is only taking the list of S object as the argument. The third one is only taking the publish S object as the argument. The second and the fourth have or are taking a list of S object plus the Apex object callback, right? So now you understand that there is a way to establish a relationship between the two classes. That is the Apex trigger, which is actually publishing the event, and the callback class, the failure callback class, which will be taking care of doing any kind of remedial actions based upon the error event that it has received. So the flexibility or the options to connect these two classes is through the publish operation, as we can see right on our screen right now. So here it is. Now list of S objects, we already have it, which is list of insurance, right? And callback. Now callback is actually the instance of the callback class. Do we have that? We actually don't have the instance of the callback class. So what we'll do is we will instantiate the instance of the callback class. Our callback class was insurance failure CB. We'll call it as FCB, failure callback class, and we'll say insurance, right? So now we have instantiated it. We do have an instance of the class, we'll pass it here. And just for the time being, we'll just say system.debug, and we'll say the results, right? The reason for doing this is because we have already validated the database.save results options in detail. We have looked into each and every single attribute of the results function. Henceforth, we'll not be going that in this particular session. It is already covered in session 2. So there are two things which we have covered. We first created an insurance failure callback class, which implemented EventBus.EventPublishFailureCallback. It had to implement a method, henceforth we implemented on failure. On failure takes in one argument, which is results, and results would provide us the event UUID of the messages. We observed that we cannot directly query into the platform event object. Henceforth, there was a need for us to have an association with the record which was publishing the platform event and the event message. Also, we also wanted a relationship between the class which is publishing it or the invocation which is publishing the platform event to the failure callback class. Henceforth, we went back to the trigger. We just created a simple trigger which looks into the accounts for which the required travel insurance flag has been checked. Once we got that information, we started creating platform events. When we're trying to publish the platform event, we noticed that we could have a publish method which takes in two arguments, which is the list of S object and the instance of the callback class. Henceforth, we instantiated the instance of the callback class and we supplied that particular value. So now we do have a connection between the class, the publishing class, and the failure callback class. But we still have one point missing. And the point which is missing is we still don't have a relationship between the event message that is being published and the record which is actually publishing that particular event message. For example, in this scenario here, the first account which comes into this particular loop results in the creation of this particular event message. But there is no direct relationship between them. Don't get confused with the fact that we are supplying the account ID into the customer ID field so you could use it. No, you could not use it because, again, you cannot perform an SOQL on the insurance platform event. Henceforth, this field is of no relevance to you in terms of associating a relationship, right? So that is where we will have to think about, or we will have to go back to our basics of what we have seen and evaluate the instantiation options which we discussed. So we discussed about two options. One was using the new order information, that is, we use the new operator. The second one was using the SObject type new SObject. Now, as I explained to you in detail in session number 2, when you use this particular option, you would be able to get the event UUID of the event message that is being published in advance of the publish operation, right? So before you even hit the EventBus.Publish, you could get the value for the event UUID of this event message when it is actually published. This is what we'll be using in this scenario. So again, trying to rephrase this example, we'll negate this line. We'll create a new line here, insurance __ E, insurance equal to, not the new operator, we will use insurance __ E. Copy this again. Dot S object type dot new S object. It takes in two parameters, as I told you. One is the default record ID, and the second one is if we want any of the fields in that particular event message, which could be defaulted, to have a default value before the publishing, right? If we want to retrieve the default values of a field before publishing of that particular event message, the second parameter of this particular function has to be set as true. So the first parameter, which denotes the record type, is null. The second parameter is set as, right? Now at this point, what it will ensure is that this instance of the insurance platform event, we could use the event UUID of this particular event, right? What we'll do is we'll create a map now. Map of string, comma, string, and we'll name it as UUID map. New map of string, comma, string, right? And what we would do is we would add, before this is being added, UUID dot put the key. The key would be the UUID, which is the insurance dot event UUID, and the value would be the account record itself. So ACC dot ID, right? So to explain it once more, we have used the S object type dot new S object declaration for declaring the platform event. Since we have used it and supplied with the second parameter as true, which would help us to get the default values of any fields, we are able to retrieve the value of insurance.eventUUID even before the event is published, actually, right? So we have that value here handy to us. What we do is we create a map and relate this event UUID to the account ID, right? So now we have a map which consists of event UUID and the account ID mapping. The next thing which we need to do is we have a map. We have an instance of the failure callback class. But how does the failure callback class get to know of this map? Simple. We supply this value to the instantiation. As soon as you supply this map value to the instantiation, you'll get another error, actually, right? The reason being because there is actually no constructor that you have defined on the insurance failure callback class. So as soon as you instantiate a class, the first thing that gets invoked in that particular class is the constructor. Since you don't have a constructor right now, it is actually throwing you an error. Let's go back to the class. The constructor is defined with the same name as the class. Henceforth, we'll say public insurance callback, and we'll say this dot UUID map equal to UUID map, right? So we'll be passing a map of string and string, UUID map. We'll save this record. Again, we'll have to declare a private variable here, UUID map of string, comma string, UUID map equal to new map string, comma string, right? So now what we have done is we have defined a constructor here in the callback class, and the constructor takes in a map argument, which is of string string. Once it receives this value, it stores it into a private variable in this particular class itself, right? Now we go back to our original class. We instantiated this particular failure callback class. We supplied it with the value, which is a map of the event UUID and the account ID. It instantiated, it assigned the value to the private member variable of that particular instance. We move forward and publish this class. This completes the entire loop, actually. So we have a calling class, we have a failure callback class. The connection between them is established through the EventBus.Publish. We pass the instance of the failure callback class on the EventBus.Publish. While passing the instance, we also pass the map of the event UUID with the record ID that is used for publishing the platform event, right? So the entire loop is now closed. So once this platform event is published, it will actually have the instance of the failure callback class applied to the EventBus.Publish. If the event fails due to some reason, or if the event succeeds due to some reason and we have implemented the success callback, we'll be able to get that response in the failure callback or success callback classes. Let's go back. Now let's review the failure callback class. Now, depending upon what is the consequent or the subsequent action which we want to take from the failure callback class, we can take the appropriate methods actually, or we can implement the appropriate actions. So in some of the cases, we may not want to republish those messages. We may just simply want to create some task and then assign that task to respective owners so that they can validate those tasks actually, which has the information about the field event messages and the account records. In some other cases, we may be required to republish those messages. So creating a task is no big deal. Henceforth, we'll talk about the scenario wherein we wish to republish those messages. In that case, we have to take into account two very important considerations. The first one is that you can only do that for a maximum of 2 times. That is, once the failure callback class is invoked, you could actually republish or try republishing the event messages. Once you try to republish it, in case if it fails, there could be one more try, including the first one. So you'll have two tries wherein you can actually republish those messages. Beyond that, you'll always have to create a fail-safe mechanism wherein you document that information in the Salesforce, and then you can take further actions depending upon your business process. But it could only be done maximum of 2 times. Secondly, we cannot republish the same event message. We'll have to create a new instance of that particular message and then republish that particular message. So these are the two important things which we'll have to take into consideration. Let's look into the example. So in order to satisfy that, I've already created a max retry variable. I've marked the variable as integer and static and final so that I don't want the value of this particular variable to be manipulated. I've created a variable as counter in order to keep track of the number of times the event messages are expected to be published, right? We already have the list of event UUIDs which have failed, and we have the UUID map. So what we'll do is we'll go through string event UUID, and we'll go through the list of event UUIDs actually. Right. And here, what we would do is we would actually check if the UUID dot contains key, right, which is event UUID, or the variable which is used here actually, right? And we'll enclose this in an if. If it does, what we need to do is we need to store that information or to store the information of that particular account in a variable. So let's declare a variable here, which is called a set of account IDs or set of IDs. It's an account ID equal to new set of ID, right? Now you have the event UUID. You're checking if that event UUID is already present in the UUID map which you have received from the publisher class. If it does, then we add it to a set actually, right? So account ID dot add, and that will be UUID map dot get an event UUID, right? So now the set of account IDs. So now you have a set variable which has the list of account IDs which are for which the corresponding event messages have failed. Once we have the set of IDs, the process remains the same, wherein what we'll do is we'll query for the account information based upon the set of account ID, that is the set of IDs, that is account ID, right? So we'll just quickly scribble that across here, list of account equal to, and we'll be querying for some information, which is actually, so let's take some context from here. This was what we were trying to publish, and probably we'll also have to reuse this loop. So let's bring it here, the time being, and we'll mark it as, right? And this is to fetch the ID, the name, from destination, and the to destination. These are the fields which we need from account object, where ID in the variable which we have for it, right? Which is nothing but the account ID. Correct. Now close this loop. Once we get the list of accounts, actually, we'll reactivate this loop, right? We'll loop through each of the accounts, and in each of the accounts, we will be instantiating the insurance object. We would actually supply the values of the platform event. And once you've supplied the values for the platform event, we would again be adding a new map. So we'll have to use a map new here. We'll declare this. Let's go ahead and declare this as a map. So we'll be using it here, right? And the remaining definition remains the same. Okay. So we've declared that new map. The list of insurance is actually, again, something which we'll have to declare. Copy paste it from the copy, we'll paste it here, right? Okay. Now what we have done is we have just whatever accounts we have received, we are just looping through those accounts, and we are trying to republish the insurance. As I told you, we have to republish that particular platform message. We cannot reuse the platform event message. So once we have the list of insurance, what we'll do is we will check if list of insurance is empty. I will put a negation here. If true, we'll again, with conventional approach, we will be instantiating, or we do have it right now. So what we have to do is list of database dot save result results is equal to EventBus dot publish, right? EventBus dot publish, and here we have to already have the list of insurance, and the callback class is this. But before we do that, we also have to ensure that the UUID map variable here would also want to update the variable which we have of UUID map with the new variable which we had created actually, right? So since you're passing it as this, which is the instance of this particular class, the next time this class is invoked, we would want to have the UUID map contain the new event messages along with the new relationship of the account ID, right? So this is not the event UUID of the event message that field. This is the event UUID of the new message which we are trying to publish as part of this particular transaction. Henceforth, we'll be adding it to the new UUID map new, and hence eventually mapping it to the UUID map. We do have some errors here. Let's look at them. Line number 40, we are saying duplicate variable results. Okay, variable does not exist, UUID map new. Okay, we do have two error messages that are being displayed. Variable does not exist, UUID map. I think the name of the variable is incorrect. We'll get it corrected. And we do have the next error message, which is duplicate result. Okay, and so we'll say results of republishing. Save this record. Okay, so now we have completed this part of the code wherein we discuss about how to republish an event message. There's one more thing which we have missed, which is about increasing or incrementing the counter ++, right? And this entire loop actually runs upon, or this entire loop should actually be enclosed in the max retry. Like if the max retry is, the counter is less than max retry, that is when this entire loop should run. But I'll keep that logic as it is for now, since I've explained you the significance of this. Right. Okay. So going back, depending upon what we want to do with the event publish failure callback class, there are multiple options in front of us. The only fact which we should be cognizant about is, in case if you're trying to republish the platform events, we have to be cognizant that we can only do it twice in this particular publish failure callback class instance. After two invocations, we'll have to resort of storing that information as an error log object record in Salesforce. We cannot try to republish it. Now, in order to republish it, we have two variables which we have handy: the UUID map, which we received from the Apex call, Apex trigger actually, and the results, which consist of the event UUIDs of the failed records. So what we did is we looped through the event UUIDs, right? That is the list of event UUIDs, which we received as part of the onFailure method. And for each event, we try to find out if we have the corresponding account ID in the UUID. Once we get the account ID, we query for the account information, and then we try to republish that particular platform event entirely. It is very important to note we are republishing it. We are not reusing whatever was the failed event message. The failed event message will be discarded. We'll have to republish. That is, we'll have to instantiate and create that particular event message once more. Once we have done that, we actually update the private variable UUID map in this particular instance, because we'll also be passing this instance of this particular class to the EventBus.Publish, so that when the new platform events are being or tried to be published, in case if there is an error, that would again call or it will again invoke the same class here. Cool. So this was all about understanding how the Apex trigger was used to publish. During the publish method, we had the options of providing a parameter for a callback class. We instantiated the callback class. We created a constructor so that we could establish a relationship between the record, which was publishing the platform event, and the platform event message in itself. We pass that information to the failure callback class. We use that to retrieve the account record. Based on the account record, we queried for the information and republished the platform events. So this covers the failure callback mechanism. There is also a success callback actually, right? But as per the Salesforce documentations, almost 99% of the platform events actually are successful, which means that in case if we are implementing the success callback and there is some subsequent logic for it, we have to be cognizant of the fact that there are chances that it might hit the governor limits. Considering the fact that high volume platform events could be huge in number, henceforth, it may create a problem when we are trying to publish the platform events at one go, or it's like a stream of platform events, and those are also successful, and we try to validate the response in event publish success callback and do some actions on. So we have to be extremely careful, but the ideology behind that is exactly the same. Instead of having the on failure method, we'll have the on success method, and it would again give you the event UUIDs. The concept remains the same. You'll have to establish a relationship between the record which is publishing a platform event and the event UUIDs and pass it on to the callback class, actually success callback class. This is all we have from this particular session. In the next session, which would be a minor one, we'll be looking on how to test the callback classes, the failure callback classes, using a test class, so that we could have the required coverage to deploy this into production. Until then, thank you. I would love to hear any comments that could help me improvise this session. So please do update your feedback on the in the video. Thank you.